application, a new section, and this one I pick up from the 10.3. In our textbook, it kind of focused almost all the applications in chapter 9 and 10. And usually we are not possible to reach even chapter 7 in one single semester. So that is my intent. Once we have appropriate foundations of the theory, I go to pick up whatever right now suitable to our learning base. So I pick up this one. And this one is called the vibration picks up. The pickups meaning designing or using appropriate sensors to pick up displacement. I mean, to pick up is to sense, okay, as a sensors to estimate or to measure the displacement, velocity, and acceleration. Okay. This is the second type. This is the second type of application. The first one is showing in back to a few lectures before, and that one is in section 9.3 about the vibration oscillations. Okay, so here I kind of give you another hint again about the how to prepare for the test. Okay. For pickups, and that refers to the sensor to measure the vibrations. And what are the vibrations we're going to measure? Usually the quantity is displacement. And to measure the displacement, then we define that sensor is called the vibrometers, or sometimes people call this seismometers. And we measure the accelerations. Measure, that means we try to measure it and using the measurement to approximate. Okay. And so that is we call the accelerometers. That's going to measure the accelerations, and we call the velometers. We measure the velocity. In these sections, the first two are the most used sensors. So I will focus the lecture contents on the first two. Velometry simply is a very simple, but in my exercise, this term to me is rare. It will be rare than compared to the first two. So, okay. So that's the contents. The first one, we can go over the introductions and get some kind of theoretical preparation before we jump to the different sensors. Okay. So basically, this introduction, I would say, really is a summary of what we have learned. So we simply pick up from what we have learned and to go over here. So this is a setup of the sensors. Okay, so you look at this diagram. So this is certain sensors and mechanical, electrical components. In that component, they have a proof mass. The proof mass, that is a little mass, and whatever the companies they made. And with the proof mass, they have a spring and they have a damping. And this one, basically, you can ignore this one. They come in the housing, okay? And these sensors mounted to the surface of certain object. Usually, the mounting is by screw. The sensor come up with the tiny thread bolt. They kind of screwed in. To be mounted, you need to find a good you have to thread the object with the same setting of the thread, and the insert can screw it in tightly. So this is the mounted onto the surface. So this representing is not the base. You can imagine this is the surface of the certain big object. Okay, so in terms of our notations, we're using Y to denote the vibrations on the surface of the object, okay, which means phase, okay? And we're using X to denote the degree of freedoms, displacement of the proof mass, and that is something going on inside the sensors, okay? And the sensors going to measures, going to output. The output of the sensor is this. Listen carefully, this is the key. The output of the sensor readings is by this recording, I would say, calibers. These calibers simply measure the displacement between, this is the 0 ground, this is 0, between here to here. So in other words, the sensors output the readings of, in terms of a symbol Z. The sensor's reading is to pick up the relative displacement. Okay, this is the key information in these applications. Okay, so keep this in mind. For example, for sensors, we're going to model as a spring, this kind of single systems. And the measures is relative motion. So here I put the information. Whatever the output by the reading, by the recording of the sensors is a relative displacement. Okay. So here for this application for vibration pickup, we really focus is on the relative displacement, this kind of concept. That is where we start from. And again, this is in the categories of the base excitations. Okay. So again, from the base excitation, we pick up our equation of motion. Everyone familiar with this one. And we assuming, say, we studied the most fundamental problem, assuming the object is vibrating at the harmonic, so we assume as this form. So relative displacement we define as this. So this is the modified equation from here. By introducing the definition of the relative displacement, we have this one. So we just go over from there to here. Everything copied to here. Okay. So that is a piece of information we pick up here. We're starting from here. So what is this piece of information? Let me go over a few slides backwards. For vibration pickup, everything we start from here. This is only one piece of the many things. Okay. So we start from here. So that is the information we start from. So go to here. Okay, so everything is summarized. The figure here and this phase diagram. So that is the foundations. So that we can start here.